All right, let's go through a couple of examples here. You'll see this one here. Well, I'm going to just treat this just like I would with algebra here. So I'm going to distribute this through there. What I'm going to get here is I'm going to get, let's see here, that'll become negative 2x plus 12 plus 3 is all greater than or equal to 35. Let's keep moving this around here. This becomes 15. All of this becomes 15. So I'm going to get negative 2x plus 15 is greater than or equal to 35. And then I'll get negative 2x is greater than or equal to 20. And last but not least, if I divide it by negative 2, I'm going to get x is, now notice I have to switch this because I'm dividing by a negative, less than or equal to negative 10. All this means here is that if it's less than or equal, so I can put a solid dot, and basically every result that's in this direction, okay, will be my answer. In other words, every result that's less than or equal to negative 10, and so it just works itself like that. Let's deal with this second example here. They ask here, is this always, sometimes, or never true? Well, let's look at this example here and see if it works. So if I have something like this, I'm going to start this off here and say, well, that's 8x when I distribute, and that'll be minus 12. That's going to be less than 8x plus 8. Now let's see how that works out there. Let's combine like terms. What I'm going to get here is if I move the 8x over to this side, and I subtract it from both sides, I'm going to get 0 is less than, now let's move that over, 0 is less than 20. Is that true? Is that a true statement? Is 0 less than 20? Is it always true? And the answer is it's always true. So when you do these, look out for what happens here. Sometimes you're going to get that maybe it said, 20 is less than 0. Of course, that's never. So just be careful of these ones when you get these sometimes, always, or never. The next one here, what is the solution of? Now, this is an and scenario, so be careful of these and. It means there's two different conditions. I'm going to follow this first one here, and what I'm going to get is I'm going to get 3x is greater than or equal to 9, which means that x is greater than or equal to 3. The second condition says that x is less than 5 when I divide both sides by 2. So I got a condition here where x has to be greater than or equal to 3. Well, here's 3, and it's greater than or equal to 3, but it's also less than 5. So it's something around here. So which means that my range here falls right into here. Okay, right up to 3. In other words, it's greater than 3, but it's less than 5. So it's somewhere in here is my range, just to show you what the and is. It's giving both boundaries there. The last example here would be like an or scenario. If it's or, well, let's solve for both of these. You're going to get here 5x is greater than 10, or x has to be greater than 2. And the second restriction here is that 3x is less than negative 21, or x is less than, that would be negative 3, pardon me, not negative 21. That's right. That would be negative 3, or x is less than negative 1. So x has to be less than negative 1, but it has to be greater than 2. So this is a different scenario. One is that if I go right to here, pardon me, at negative 1, less than negative 1 would be in this direction here. Okay, and the other one is greater than 2, which is right here. And so really there's two boundaries, one going this direction, the other one going this, and they start at different places. In other words, this region here never is dealt with. Okay, that region is never dealt with. And so just to show you what this looks like on a line there. But this is basic equalities. Here's some examples, and you can do a few more just for practice later.